one moment to get this set up. One thing I wanted to talk about that was asked during the exercise was with the bomb balloons, we want to be able to make them clearly visible. We can modify the text properties here if we need to. Obviously, we want to set this up so that we don't have to worry about it. If we hit jump by selecting the model and we go to our component tree, and if I open this up and I right click and edit the model, so I'm going to right click on the model, the little yellow Lego brick, and say edit model. In here you have your bomb balloons attached to the model, and they have text properties, bomb item 1, 2, and 3. Bomb item 1 is the one that is pinned to it. And what we can do is just edit the text property in the database to say that we want this to be much larger. We can also choose where we want it to be positioned. Right click, save to the database. Right click back in our project, date and project, and now it's showing a lot more. You can of course then modify it here. One thing that I find that I'm doing is actually making the redundant ones invisible. And one thing that I would like to see in a future version of NA standards is the option to, if there's already one called out, that it will actually just show it for one of the devices, not all of the devices. But something for the next release of NA standards, or a future release, I should say. They don't just add stuff because I want it. That's that first piece. Second piece was just to be clear on the setting piece for the bomb. If I go to the settings here, for NA standards, I needed to add a fixed space item space designation to get the omit device attribute to work. And I'll show you how I kind of found the correction for that. To do that, I'm going to go to the database editor. I'm going to go to format, and I'm going to go to text types. Actually, no, I'm not. Sorry. I'm going to go to attribute names. Inside attribute names, there is a column on the left-hand side, which is how the attribute is read in scripting format. So all of these attributes can be used in scripting, but in most cases they don't have any spaces in between them. them, and they might have a shorthand in the script that may not be the most clear thing that we want to use for how we display it in DTM. If I go down to fix device name here and fix wire name, you'll see that fix device name in the latest release was changed to fix item designation. And fix wire name. Fix space wire space name. That is kind of how I found that. You can see that it's a yes or no condition attribute type, and you'll see that the owner here for device name device name has an owner. And you can come in here and see what can be a potential owner for a device or for an attribute. So if we look at our sheet related ones, or one like customer address, that's related to sheets, so sheets are the only owner. You could argue maybe that you want to have that as a project property as well, and have multiple owners. When we look at the cutting length attribute, the cutting length attribute is a string that belongs to cable core, cable type, core type, and bus bar type. And then a BOM ID belongs to a cable, component, connector, or a device. So on the BOM, Toolbox BOM, what if you have more than 3 items? On the BOM balloons, what if you have more than 3 items to the assembly? So you can add additional components. So I think I have an example here. File before I share it. So right now, I want to say that the trying to decide how we parts either exist in the database or they don't exist in the database. Right now, for us to use Toolbox BOM correctly, we would need to have a part in the database so that it could read it. Script can only look at parts that exist in our database over here. Additional parts is a way to do a shorthand if you wanted to add an additional part, but didn't want to necessarily create a BOM part for it. You could add it in here and say, like, for this ice cube relay, I want, you know, the base, I want the relay clips, and I want the wire holder that goes on there. These that currently will show up in the build materials, but if they do not have a dynamic part, then they don't have a description. Sorry, they're not in the database, then they don't have a description, which is what the BOM looks at. So if I look at this example, the relay clips are actually in the in my database as a part, so they do have a description attribute, which is why we see them here. Whereas these are just additional parts that were added to a different component, so it reads them as not found, right? Now we can always come in and edit the text properties if we need to, or add them in, but that kind of defeats the purpose of what we're trying to accomplish with this. So if we were to make this a part and then add it as an additional part to a component or a device, then it would be reflected in the BOM. Right now it breaks everything out. It does not it will treat each part of an assembly as a separate part and reflect it out unless we specify that in our settings. As far as the BOM balloons go, it's going to treat any model that's represented as a component, and if it has a BOM balloon, it will be added. If it's an additional part, like in the case of these relay clips or things like that, they will not show up because there's no physical model to be represented. I hope that answers that question. You can tell me if there's further pieces. Okay, great. Last thing we want to talk through on a schematic. Schematic side of things, I want to be able to create off-sheet jumps. So if I want to show a jump from this sheet here to a previous sheet, I think where that went. Okay, so I want to make a sheet jump from this terminal block, jump out, and jump to a new sheet. So I'm going to use my miscellaneous tab, database, and I'm going to go to, so there is a miscellaneous signal cross-reference where you have a lot of different types of placement here, like ones like this. Those are good for the top of sheets for headers, things like that. In this instance, my personal preference for something like this would be just in the signal reference folder. I'm going to place signal reference here, and then on my next sheet over, I'm going to place a destination horizontal. And I'm going to add a connection without using a wire. I just have 132 here. If I right click, I'm basically transferring a sheet reference. I'm going to use point to point. And then on my 300 sheet, I'm going to right click on this off sheet jump, go to sheet reference, go to point, right click again and go to sheet reference. And then I can see I have the currently selected reference on this sheet, and then I have a list of different options. So let me add in a couple more. Force horizontal. Horizontal. Point. The shortcut here is to select it and say Shift R. Make it point to point. Make a logical connection without a wire. And then if I right click and go to sheet reference here, I can see any available destinations that are available in the project. These are all sources, and it's looking for destinations. If I come back here, do the same with my destination. One here. Select this one, Shift R, point to point, R, point to point. Select this one again, Shift R, and I'm going to use 10 as my reference from the other sheet. Hit OK. Select it, Shift R, make it 32. You can also share it. I can go back to that 10, so I can say this is going to both of those locations. This one, third one. Now I'll go back to my 200 sheet. I'm going to add a 60 light wire. So this is 67, 68, and 69, 300. And without adding any additional wires, I'm just going to add a attribute text for core name. I got my order screwed up, but here's wire 67, 68, 69. more for coming down at the bottom of a sheet here, whereas these signal references here are more for like calling out individual placement. If I wanted to a app for connecting. So that if you want that signal cross-reference, that's more for like, ladders for sheets. Put the source at the top here. Destination at the top. Have that there. And another one, bottom. Oh, that was a good question. More questions? Great. I'm not sure if my mic muted itself there. Did my microphone mute itself while I was talking through the offsheet jumps? Okay, but we raise your hand if you heard me talk about. Okay, that's good. I have done that before, and it's I won't tell you how long I talked for, but I've done that, and that's okay. We'll switch over to database here. I'm going to keep an eye. If my mic cuts out, then please just raise your hand. Best way for me to see it. Okay. Switching over to database. So database basics. We'll talk through. Sorry, I jumped there. Talk through the configuration. We'll talk a little bit more about attributes. We'll talk about text types. We'll talk about lists and wire definitions. Then we'll talk through sheets. We'll get This one is important because you will want to obviously have your own title block. So we'll talk about importing a existing title block and changing the text. That is going to be something that I would encourage you to do before you get to your first coaching session, is get your sheet in. So if you want to put down a note to get that title block set up, just be thinking about that as we go through the sheet exercise. We'll look through the workspace, and then we'll edit a sheet template. We'll talk more about the database library objects. We'll talk more about configuration and attributes and some other additional pieces like translation tables, which is useful if you are working in an environment where you might have teams that are in different countries, or you have team members in your manufacturing that speak a different language. So you can have translation tables set up for, identifying key technical terms and translating those. If you were to move from DTM in English to German to Spanish Spanish, whatever it may be. Then we'll talk about symbols, right? So when we think about database, I want you to think about a single component that is made up of a physical model and a collection of symbols. And then all we're doing in Database Editor is electrifying those parts by bringing them together on the component level. So we'll start with the symbol. You'll build a symbol for a relay. Then we'll lay out the model design. So we'll do the physical model for that relay. From there, we'll go through setting up mounting types, slot points, offsets, gauge restrictions, and then you'll build that part from scratch, okay? At the end of today, we will cover the advanced model design pieces, so adding cutouts, drill holes, restrictions, space requirements, and then you'll make some drill hole and cutouts. And then to cap it off at the end of the day, I'll talk through model characteristics, which is kind of an advanced piece, and we'll cover that when we get there. We won't worry about this too much right now. Okay. So again, we're going to bring it back to this idea of being agile, and the idea of the best way that agile has been described to me is there is a style of work that is considered waterfall, right? Where you think about what you're trying to do, you think through all the different pieces of it, and you try and achieve that, and then you move it into its next piece, right? Agile is trying to break things down into its simplest pieces, and it's trying to break things down into what can be achieved step by step. The best way that's been described to me is don't spend your time trying to build the perfect hammer. Build a hammer that works, and when it breaks, build a better hammer. Okay, so the way that I like to think about that as far as DTM, I mentioned it during the schematic piece, was breaking this down into I just need to get my first project done in DTM. Okay, from there you can start to make corrections and changes as you move to your second project. You learn from the first, and then you can port. From the database perspective, there are millions of parts that are used in this industry, and so to be able to provide you with a robust database is a challenge. It's something that our team has as a high priority. We work closely with Cadence, who is Component Cloud, ECAD port. We have a partnership with Rockwell, Allen Bradley, to get as many of their parts available as we can, so we can help support that effort. But realistically, you want to be looking at all times into what is the bill of materials for my upcoming projects. Your database will build itself out over time, but there will continue to be that need to kind of build parts as you go through. So be thinking, in this case, what are the parts that I need for my first project? What are the parts that I need for my first 3 projects, right? Start building those out, start getting parts from the component cloud, getting parts from set models. The thing that is a challenge with the parts, especially, is if you have specialized parts that come from specialized manufacturers, maybe not necessarily a Phoenix contact or a Wiedmuller or an Allen Bradley or a Siemens, but more of a shop that makes a very specific tool for your industry or a specific component. Those are the ones where you will have to consider building MVP parts or requesting step files from that manufacturer if they don't have them readily available. But breaking it down into its pieces, understanding what you need to do to have a part that's functional for you to finish your project, and what are the things that are nice to have. So there's, I must have this for the part to work, and there's things that are like, it'd be nice to have that. Do I need a step model to complete a project? It's really nice because it looks clean, but is it a requirement? No. If I have a transformer that I can define as a cube with some simple graphics, because I don't have access to a step model, and I can give a relative position of where the pins would be for that device, that is more than sufficient to keep yourself moving forward. Do not get hung up on the whole practice of having to have perfect parts and have them perfectly represented before you can move forward, okay? So we'll talk about that a little bit more, but that's just kind of my advice to you as you start to build out the database for your projects. The user story, in this case for the librarian, which is not a separate person, it's kind of just a mindset, you know? There might be multiple librarians who are using DTM, multiple people who are building parts, or you're divvying out parts to be built. So you want to outline what you need out of a part. As a part that we need for our project, I need X, Y, and Z. Those are just conversations you want to have. Those become your requirements. You design them, develop those parts, review them, make sure that all of the pieces are there. You want to test those parts, and then you want to add them or make them a part of your standard library or your standard database so you can use them for projects. Demonstrate what lessons have been learned, you know, and then you want to go back through this. So it's kind of a continuous piece. So we'll talk through this slide. I like because it gives you a good reference of how to look at parts in your database. It's the same DTM software, right? We're looking at it from a different perspective now, because behind the DTM panel is the database editor, and it contains all the things that we need all in one place, but they're broken down into their respective parts. So you have basic schematics, which are going to be just texts, graphics, symbols, symbol pins, and any logic we want applied there. We then have schematics for things that are physical models that have physical restrictions on them, like gauge or the number of wires that can be terminated on a pin, things like that. And then obviously on the panel, you will have a combination of text, graphics, symbols, logic, step models, ports, mount slots. So this kind of gives you kind of a checklist of like, these are the things I need to make sure that I have in my. So to you know, take this out to some basic level, there's a couple different ways to get into Database Editor. I can show you. The first way is from the DTM panel, go to Tools and start Database Editor. Okay, that's the first way. The second way is to be looking at a specific part. You want to right click on that part. You want to say, I need to do something with this in the database editor. I'm going to jump to my component tree, and I can right click on the part and say edit. And it will pull up the the component level, which if we look at my editor tree on the left here, this is the component level, the component folder, which contains 6 symbols and a physical model. And because this is premium, I also have a view. If I want to look at this part from the model, I'm back in DTM panel. I right click on the model and I say edit, and it pulls up the model in the model folder of my project editor tree. If I come back again to the project and I want to jump to the symbol miscellaneous tree, I'll look at the symbol that is being used from my database, right click and edit, and now I open up the symbol in my symbol tree. So you can see I already have a few things open here. The thing that is challenge, or the thing, it's not a challenge, but it's just something to be aware of, is when we're working on one piece of a component, whether it be the component level, the model level, or the symbol level, the database will act in a way that it will not update in real time. If I'm going in here and I'm making changes to this physical model, I'm not going to see those changes here, okay? Until I close this out, make the changes, right click and save to the database. Then when I open it up on the component level, I should see those changes reflected. But it is really a check-in, check-out system, okay? The database functions kind of like, it acts like a library, right? You have to check out something, modify it, change it, check it back in, and then open up another piece of it, check, make changes, edit it, and then you can check it back in. If I were to make changes here, so I'll make a simple modification here, like industry gray color. I'm going to save this change to my database. It's going to tell me it's used by 2 components. Okay. If I come back to the project, jump to the panel, you'll notice the part remains unchanged. If I want to make that change, again, this project is kind of suspended in the time that I opened up and first opened this project. It took a screenshot, it took a snapshot of the database, and that is what I'm currently using for this project. If I need to make a modification or a change, I can do 2 things. I can update individual models or symbols or components by right-clicking on the model, the symbol, or the component in the library and say update. Now you can see I have my lovely industry gray component next to my 2 other industry gray components. The other option is if I'm making mass edits, I can scroll all the way up to the top and right click. You can also right click, I should point out, on a class folder, and I could say update all components in the project. It will give me a list of all the changes that have been made to parts in the database as they relate to this project file. and then I can either select all or some that I want to be updated. So you can see since I last worked on this project file that there's been some changes to my database. So I can choose to update all or update none, some. I can also opt to only update component attributes. So if there's a need to just update technical information, I can do that here, and it will only change the component attributes. It will not change any of the physical properties. So that can be helpful if you feel like you need to make a correction, but you don't want to break anything physically here. I can also update the configuration in the project, which basically is if I added any attributes to my database or new attributes or made changes to attributes, I can choose to just update the configuration. I can update functional units in a project, so that would be changing things from metric to imperial and vice versa. I can update device attributes. And then I have the option to create a brand new component, a brand new symbol, or a brand new model. So if I was to create a brand new symbol, I could just left click here, and it brings me to my empty new symbol worksheet here for a symbol in my symbol tree. Same thing applies here. You can do the exact same thing from the database editor side. I go and find the part that I'm looking for, go to component, and open up a component, right click and hit edit. I can also create a copy of a component by selecting that specific component and saying new component. So if you have a bunch of fused terminal blocks that are identical physically, they all use the same symbol. The only thing that changes is the fact that I have a 5 amp, a 10 amp, a 15 amp, and a 20 amp version. Then the best and easiest way to change that is just by right clicking on the one that you created, the existing one. We'll look at something like this, like a fuse. Right click, say new component. Say that I want this to, I have a 5 amp, a 6 amp, or 5 amp, what's that? HJT 50, 60, and 70. Say I need an 80. HJT 80. I want to reference the already existing part. Change all my spec sheet data to match the 80 version of this fuse. So it's a 80 amp. Now this part might not exist, but I'm just using this as an example. Say my current is now 80 amps instead of 50. Hit next. And then I can use the already existing structure, which is basically just a fuse symbol, okay? Make a new copy if I want to edit something in it, or do a completely new structure, which was just completely blank. But if I was to do that, I could say use current structure, hit next, save it to the database. Now I have an AJT 80 amp version of that fuse, and I just did it based on the fact that everything else was already done when I built this first one. Okay. If I want to delete something from the database, I just right click, hit delete. I get a warning that says, do you want to delete this component entirely from the database? Say, yes I do, and it's gone. The last place to open up Database Editor is from your shortcut. So if you open up your Windows Home button, scroll all the way to the bottom, you'll see a Zukin folder. In here, you'll see a option for the version of DTM panel that you have. You'll also see a shortcut for database editor, and also connected fabrication, which is for your technician who uses connected worker wiring or assembly. So you can pin this to the start as well by right-clicking, going to more. You can pin to your taskbar, so you have that as an option. If you don't want to open up panel, you can just open up database editor directly. One last thing, you cannot open project files from database editor. You have to open them from panel. So if I go in here and try to open up one of the schematic exercises, I will get an error that says it's not able to be opened because it is not a valid database editor file. However, we do not typically save anything in the database editor as a .e3s file. When we are done working on something, we just want to right-click, save it to the database, and then when we're done with it, we just it's saved. We right-click on that thing that we're working on, and if we want to declutter our workspace, we delete it, which is kind of a it's maybe not delete is maybe not the best word to use here. You're deleting it from the tree because you saved it to the database. You say delete. Now on my screen you'll see that next to this symbol there is a little asterisk, which means that there is unsaved changes on this component. So as soon as I go to delete it from my tree, I get this warning that says this operation will permanently save the symbol type to the database is used by partners, and do you want to save it? And I'll say I do not, because I didn't want to save any changes, and it will close it. So that little asterisk just tells you that there's been changes made and it have not been saved to the database. So I would need to come in, right click, save to the database, and then I can delete it from my tree. But just think about everything in database editor as checking something out, changing it, checking it back in by saving it, and then you can then remove it from your tree. But it's not removing it from your project. Okay. One last thing. I see this quite a bit, so I want to make this point here. You cannot edit a model or a symbol from the same from the component level. So if I open up this PLC, and I want to try and make changes to the physical model, or I want to change parts in the symbol, I cannot do it because I'm not in the right location to do so. If I go to the component properties here, and I look, I can change all of the component properties. Here's all of my technical information. Here are my pins with all of my different symbols. I have my pin assignment. If I right click and go to model properties, I can see my mounting description. I can see my model properties, but they're all locked. Can't change them. I can't change the name. I can't add a characteristic. Go to the shape. I can't change any of the physical properties. Go to the slots and pins. I can't change any of this because I'm not in the right part of database editor to do that. If I open up the physical model, right click and edit model, now I have opened up the right place to be able to make those changes. So I come in here, I right click, go to model properties. Now I can modify my technical or my attributes for my model. I can modify the mounting description. I can modify the slot point. I can adjust my slots and pins. So I have to be doing it on the right level. Lastly, and I've said it before, the symbol should be agnostic. It should not be that you're building a normally open contact for one relay. You should have one normally open contact symbol that you use for all of your relays, okay? So the critical settings that you want to consider, and I will go through the changes that I like to make for my database settings. There's some critical pieces. You want to specify, obviously, the measurement units that you want to use. You want the library's own default settings template file. You want a subsidiary. You want some certain options turned on. The two there are tooltips and Copilot. Show you these. When I go to settings for database editor, it's like a smaller version of the settings in Panel. On the first page, I select what my measurement units are by default. Database editor does not save projects because we don't save .e3s files. We can if we want to save like progress, or like we're working on stuff we don't quite want to save it, we can save it as a .e3s. But typically we don't want to clutter ourselves with a lot of database .e3s files. The initial settings are read from a .e3t file. So this is your template file. This holds your settings preferences. So in here, I want to map to station. You have your project ANSI template settings, and so on the inverse, you have your database ANSI template settings. Okay. Things that I like to turn on are my snap size. And I'll show you why a little later on. For my display, I want to show tooltips and I want to show Copilot. Let me come back to both of those. So for the symbols, when we open up a new symbol, we can choose what our sheet format is. We can choose our working grid and our views. This is what most people use, which is the symbol board. It's a small board here. I generally would prefer to use an ANSI-D sheet because ANSI-D is the one I use the most often. It also helps because now I can see how my symbol is going to look in relation to the sheet that it's actually going to be sitting on. Okay. The next is my working grid size. So because all of my schematics are set up at my symbols are half-inch spacing apart, I want to be my grid size to be some increment of that. So I'm going to set mine to 0.125, which makes my snap size a half measure of that. I want my grid view to be the full half or a half inch for my points, and I'll set my ruler to 1 inch. My alternative grid size is going to be a increment of my working grid, so I'm going to set it to 0.0625. I'm going to hit OK. symbol, you'll see that it actually appears on the ANSI D sheet. So I can come up, I have plenty of room. If I was doing something larger, it would be reflected nicely. So like that PLC digital input, I can set up or create that symbol very easily. And then you'll see my grid is based on that spacing that I created, that grid that I created. So I'll set this to 4 inches by 1.5. I have an origin here. I could specify right here. That's on my grid as well. And then my first pin node would also be on that origin. Okay. The tooltips are here, and Copilot is right here on this display page in my settings. So showing tooltips just means if I were to hover over something I get this yellow context bar that says this is model ABN LC20. Its size is 4 by 4.5 by 3. That's your tooltips. If I hover over a symbol, it tells me what symbol that is. The Copilot is when I'm making drawings here. Tooltip is if I were to draw a graphic line here, it's showing me the dimension of that line. Okay, so I want this to be a 1/2 inch. Another 1/2 inch. Now, if I want to move this, I'm moving it along my grid. So as I'm moving this on my grid. If I want to move it on my alternate grid, I just hold Control, and it's going to move. So it's moving at 1/8 of an inch on my regular grid, and if I hold Control, it's moving it on a 1/16 of an inch. 1/8 of an inch, 1/16 of an inch. And the other thing you want to make sure is CTM, you have to be right on the object that you want to move. Now, what is the top piece here, this snap size? That's basically just has to be greater than 0. But what that allows me to do is then if I had a circle here, 1/2 inch, rectangle, I wanted to have, and I wanted to move something, I have this snap move mode in my bar at the very bottom. I can turn this on, and now I can actually move in on specific points. Now I can actually move this based on either the center or the left edge or the right edge by turning on my snap move mode. I can right click over this object and move it. And then most importantly, and probably my best friend in is the ability to hit P and specify a point. If I want the center of this to be right on the origin, I hit X and Y 0, and it drops it right on the origin. Same can apply for circles here. I move this, and I want to move it right over there. I can do that. This is fairly straightforward on the symbol side. When you get to the model side, the challenge is getting a grid that can compensate for things that are made in metric measurements, so they don't quite align. That's where the model grid is going to be a lot finer than the symbol grid. Okay. So all of these changes that we're making right here, we can modify the highlight, the width of the highlight. We can look at changing our default language. And then of course we want to have a certain set of sheet format and working grid for symbols. We want a certain grid for components. And then if we look at our models, you'll see that the model grid is very fine. And you'll see that you actually can modify this sheet to be a max board, which would be the appropriate size for maybe bringing in an enclosure or bringing in a standing cabinet. So you want to use an extra large board if possible. So each one has a different grid setting. The other thing you can define is a default min and max cross section. So if you were like starting out and you're thinking we're not building projects here, or I don't want too many restrictions, I could define a range that I wanted to start as my default value for components. So 16 gauge being a default minimum wire gauge, and 2 gauge being a default max wire gauge. Zoom, pan, this is similar to panel. You can change the sensitivity of your zoom in and out. You can change the sensitivity of your pan. You can also enable pan with arrow keys. The other one that's important is included elements in area selection. So if I have a collection of, so I've got a pin here. My pin here. Now for a and then I have some text that I want to add. Making a very simple symbol here. Got some text here, I've got some graphic lines, and I've got a origin with 2 pin nodes here. Thing that can be a challenge is saying, So we were looking at this part, the included elements in area selection. Basically what that means is when I'm grabbing something, do I want to exclude something? So do I want to select symbols? Do I want to select text? Do I want to select graphics, connect lines, net nodes, attribute text templates, or dimensions? So we turn all of these off, except for text. And I go to grab this, it's only going to grab the text. It's not grabbing the graphic and it's not grabbing the pin. Turn this on, if I grab this, it's only grabbing the graphic properties. Only grabbing the pin nodes. I have a dimension here. Grabbing dimensions. Grabbing dimensions, then it will only grab the dimension. So that can be really helpful for helping you modify or edit things as needed. You saw here, we're just looking at what a symbol is. A symbol is a graphical circuit element that can be assigned to a component. And again, you'll hear me say it again, they are designed to be agnostic. I mean, there's always going to be a case where you have something that's industry or like component specific. But for the most part, you want to keep your simple symbols as agnostic as possible. Okay? They don't affiliate or they're not exclusive to one specific component. They should be set up to be associated with all components. That's where these text attributes are really helpful, because you want to leave these open, right? And then they're just sitting there waiting for whatever their corresponding component is. As soon as they get added to a component, this component code becomes the part number. The pin number gets assigned based on what the component tells them the pin number is. The higher level assignment, location, and device designation come from what the project says that symbol component. But all it is graphics, right? It's an origin, it's attributes and text types, it's graphics or line art, and it's pins and nodes. Other types of symbols. The biggest one that's maybe a little bit confusing is the fact that from a design perspective and how we set up parts in DTM database editor, a sheet is technically just a giant symbol. It is graphic properties, it's text attributes, and it's images. Okay, so that is why you will create a sheet that is essentially being treated like a symbol in the database editor. There are the standard normal types. There's attribute text templates. So for example, one that we have been using is our wire marker, core diameter and color horizontal, hit edit. All that is a symbol with an origin. It's got a graphic line that's just an angled line here, and then two attributes saying what is the cross section of what's on this origin and what's the color. The difference here is if I go to symbol properties and I look at the type of symbol that this is, it's an attribute text template, meaning it's basically a wire marker that's looking for it, and it's the software is designed to say whatever the origin is sitting on, tell me what that property is. You have connectors, you have panel sheet, you have a regular sheet, you have a table, terminal play and jumper symbols, pin templates. So these, reference destinations or reference sources for our off-sheet jumps. So you can go in and kind of explore the database a little bit, and you'll see what each of these of the ones that already exist, how they're set up, and how that is reflected in the project. So use the existing symbols and components as a frame of reference. Those are the best way to tell you how to set up a certain thing. Symbol template types, sheets, shield symbols, signal, pairing symbols, things like that. Your bomb balloon, those are all types that you can have created. So then what is a component? A component is an electrified model and symbol. It is the place where the model meets the symbol and the two are connected together. When we look at a component in the database editor, this one's a little bit dense, so we'll find something a little bit, yeah, and here. I get this by basically going to my model tab, placing a model on the component sheet, finding a symbol in my symbol tab of my database, bringing that onto the sheet, and then essentially creating a connection between these by selecting pin nodes and pairing them with their corresponding physical model pins, right? That's how this works, and we'll talk about this. So I showed you this a little bit earlier. This is your attribute list. This is where all of the attributes live. So you can click Format at the drop down at the top of the menu, select attribute names. You will see all of the important attributes, including those that are used for those add-ons. Ones that you've already seen are the project attribute project version, the component attribute BOM, and the sheet attribute document type. Okay. The first column is the name. That's how it's read by the API, by the script. The display name is how that attribute is represented in the in DTM for the user. The type can include integer, real, string, yes or no, or a linear measure. So if it's a cutting length, that's going to be a linear measure type of attribute. We talked, I showed you the different types of owners, okay, for those sheets, and then we can specify if they have some special characteristics, okay? Main thing here is attribute owners are needed just to filter out attributes that don't belong. So we declutter our object dropdowns. That's really the motivation behind the owners. You don't want to see sheet attributes. You don't see 100 sheet attributes between you and trying to find manufacturer for a component. Okay. The explanation of the columns. So there's some columns in here that we can look at. Signal instance is saying that that attribute may only appear once on the assigned owner. So if it's manufacturer, there can only be one manufacturer of that component. So we don't want to see 6 different manufacturer attributes for a device or a component. We can define a unique value as a starting point. We can format it as a name or value. This text string will contain only the name, only the value, or both, depending on what you choose. You want to define the size of the spacing for the attribute, which doesn't honestly fly in most instances. The color defines an initial color code. I don't think there's any examples of where that's different. We can define what level they show up on. We can define if they are visible or invisible. We can say if it must exist or not for a component. So like for a cable or component, it must have a class of some kind. We can define if it's changeable by script. We can define a default value for that. So if the attribute is designer or user, engineer, designer, if you want to always have your initials set up as that value, you can. And then for certain attributes, we can define a list of values. So if we were to go in and look at database user, we have a list of attributes that can be used there. Any other good one? So what does that look like? If I go to format and I go to attribute lists, I can create lists that basically give me some predefined options so that I don't have to type them in. The idea being that you want to limit any kind of discrepancy or change in values. So for this, in this example, I have a training attribute where I've listed a bunch of different AMP ratings. I can say OK. If I go to format and I go to attribute names, and I go to the attribute rating. Rating applies to a cable, a component, a connector, a block connector, or a device. I'll come over here and I will define a list of values that I want to use, and I can use training as my list of values. Okay. Save the changes to the database. Format, go back to attribute lists. I'm just going to rename training to current rating. So now let's say we're looking at this component. I want to right click and go to my component properties. Go to component. I'm going to add the attribute ink. And now if I hit this drop down, get a list of because, okay, that's why. Because the rating already has different values, it's providing me with my list, but it's also providing me with any other entry that is currently in that rating attribute, which is probably 100 other devices. Let me use my other example here. I should just see a list of what I have assigned on that. But again, that's just a good example of some of the database pieces here, where it's like, there's already some values in there, and the whole point of the list is to be able to reduce that. For additional parts for DT series, like just being able to write this out, you might have 6 different instances of this first entry if you were writing it by hand every time. Because all it takes is a capital T or a space where there isn't one, or an extra semicolon where it should have been a comma, and then you basically are generating reports, or you're pulling out stuff that just has a bunch of redundant information in there. Perfect example, if I can find it, model, properties. If I go to list more descriptions for my mounting description, all the way down, yep. Okay, it's going. Okay, like one example is, I had for a longest time like TS space 35 space millimeter, and I had TS 35 millimeter no spaces, right? And then that just kind of creates a compounding like issue in that sense. So that's a limitation of the database. Obviously, that's just good database management. Try and avoid creating, redundant pieces there. Next, I think we move on to text types. Yeah, so you can add list as an option there. Assign that list to the attribute, and then okay, so we'll save this for after. Okay. We'll go ahead and get started with our next piece here, which is the sheet. So we pulled open a sheet. I showed you how to do that. You right-click on an existing sheet. Go to our miscellaneous. Go down to miscellaneous underscore sheet. I'm going to use my ANSI D sheet. I'm going to right-click, and I'm going to say new. So now, instead of the ANSI D sheet I had here before, so this is where I right-clicked and edited, and I open up the already existing ANSI D sheet. When I right-click and say new, I've basically created a copy of this sheet that does not have the same name. If I right-click from here and go to symbol properties, I'm going to pull up a symbol properties window. This is where I can name my symbol. So this is going to be my training ANSI D sheet. And for sheets, we can provide characteristics. So this is going to be my ladder. Maybe it's 1 inch for this one. Ladder. I can define a version. I can define an author. So the version text is your author. I prefer to add my organization, and then I timestamp it so that I can see where I'm at with the version text. So version text 2025 is far more knowledgeable than version text invent 2022. Okay, so it helps you kind of track that. Type is a sheet. Obviously, we could provide a letter code if we want to, but that doesn't apply here. For sheets, we can define a couple things. Is it an electrical sheet? Could it also be used for hydraulic or pneumatic or single line diagrams? If I want to use it for single line diagrams, I just check that box and hit OK. Single line diagrams are limited to a premium license, just so everyone's aware. And then we can add in our descriptions. We hit OK, right click, and save to the database. Saved, and now it shows up here in my database. You can delete it, go back, right click, and edit it, and now it's open up in here. Let's just make a couple changes to this one just so you can see how that looks. I'm going to delete this one so I don't end up accidentally editing it. So in here you have basically just I have my sheet, I have some text attributes down here. I can add in other text attributes by going up to my fixed text. I could add in a attribute, and you'll see that I only get the sheet attributes because these are all of the attributes that have sheet as an owner. So let's say I wanted to add in the sheet text special note. I'm going to select special note, enter symbol text by hitting the capital T in my taskbar. I can even set a default value. Hit OK. I'm going to drop special note 3 in here. And if I look, I can then see that that is predefined with that default value. The thing that's helpful here is to note I have a couple different ways to view text. I can display text content. So text content looks like this. If it's blank, it will just show as an X. This is fixed text, so this is dumb text. So it's showing as the header or the title of what I want displayed here. And this X right here is something that would need to be filled in, or I can give it a default value. So in this instance, let's say that the standard is always going to be defined as ANSI. Hit OK. Typically I can then come up here, and say that my first status will be manufacturing. My change is always going to be version 0.0. My date I could leave, and if I'm always the one who does the drawings, then I can say modified by me is always the starting point. Some attributes you won't touch, but like if I wanted to come in here, I could give myself a better indicator, like, enter customer here. Order number here. Just to kind of give myself some clues here. it a little bit clearer to see. For Title 1, you might say this should be the project name. And for Title 2, you would say I want this to be the sheet. Drawing number, I could put in a default guide, what that drawing number should look like. The most important thing here is just getting the attributes set up the way you want them, find the appropriate attributes for your sheet. You want to make sure that your boundary is around your piece. The other thing is your drawing area. So in my taskbar at the top, I have sheet drawing area. I select that. This will define the default location of my panel layout. So if I chose panel as my sheet, I would say this is where I want my default panel layout to begin, where I want it to appear, and I can then set that here, or I can reset the fit drawing area by hitting the blue box with the arrows inside. If I want to see my sheet layout, I turn this on and I can see my rows for my schematic. If I want to modify them, I can go to symbol properties because it's treating this as a symbol. Go to sheet layout, and I'm going to define a column as half of that. So we'll say now you can see I've actually modified my row structure here to only be on this left side, which would be useful if maybe I wanted to have a 2-ladder table. If I wanted to add that second ladder, I could come in here and select table, create a new one. I'm going to define the left edge at 16.125. Edit? No, it was left edge 21. Upper edge at 21.5. Then I can define a number of columns and rows here. So I'll say this column is going to be 60. My row to be 1 inch. So my spacing is a little off here, but this would just then essentially be how I would want to define a 2-ladder system. Now I'm doing this all by individual layout. Ladder was set up for a different product made by our partner Zukin. So for it to work in the NA standards, I would get you to reference setting it up as an individual and set it up similar to the structure of any of the ANSI sheets that you see in the library here. Once we have that, you can define the height, width, and margin here. It should be, defined for whatever your physical paper is that you out. Okay. here I have a 2-letter row, and then I would just want to bring these over and drop them correct corresponding here. And then I have my 2-column version. I would then have as setup. Okay, so that's kind of the sheets. If you want to have a panel version or a panel characteristic, it could be one that has a chess grid or checkerboard pattern that you use. I don't. I mean, it is a possibility. I don't see that too commonly in panel shops personally, but if that's something that you want, you can do that as well. Most important thing is just understanding how to add text types on this slide and understanding that you have to toggle between text display, displaying the text content, or displaying the text type. We can also display the text numerical value, which if I go into Database Editor and I go to Format and Text Types, you'll see all of the text types that are available to you. You'll see the text name. You'll see any assigned attribute that belongs to that. So if there's an attribute with an owner that belongs to it, you can assign that here. The one thing that might catch you out, especially with new attributes, is the max length. So if I look at that special note attribute that I had, special note here, it was limited to 15 characters. So I wasn't able to type out a full sentence as a special note. It's only 15 characters. You may find that you want to modify or just adjust these slightly. I would also encourage you to just rename existing attributes. If title 1 is not something that's going to help you, you want sheet title, then make that correction to an existing attribute before creating a whole new attribute, okay? On that note, on that page, the attribute text types all have a number. So text type 1, 2, 3, 4, 5, whatever. If we go over to display text type numeric, that's where we'll start to see these as those text type numbers. Display text type and display text content. This just talks through that defining that sheet drawing area that outlines the space where your panel can be placed when you choose a panel. You can also note that there is a sheet column attribute and a sheet row attribute available. Go ahead and get started with exercise 1. So for Database Editor, there aren't, apart from the one exercise, there's only one exercise file. Or there's, so you will actually not be using any, for this exercise, you'll just be opening up Database Editor and following the instructions. There is no exercise file for exercise 1. We're just creating new sheets or copying existing things that are not see any open up the exercise instructions, follow the steps in there.
Mm-hmm.